Let us see some multiple choice questions in sampling theorem. Okay, let us start with the first question. In communications, the sampling technique leads to A. high speed, B. more efficiency, C. low cost, and D. all the above. The answer is basically, if I use a sampling, we are doing it to increase the speed of communications. So, the answer is high speed, that is A. Let us see the second question. The minimum sampling frequency is called A. Nyquist sampling rate, B. pulse rate, C. Carlson frequency, and D. none. Okay, the answer is very obvious. We have been studying very hard for this. The answer is simple, Nyquist sampling rate, that is the minimum sampling frequency. We are calling this minimum because our condition is Fs is equal to or greater than 2 FM. So, which is the minimum frequency that is needed. So, it is called as the answer is A. Let us see the third question. According to the sampling theorem, the signal should be sampled at least A. twice each cycle of its lowest frequency, twice each cycle of its highest frequency. The guard time should be kept as large as possible, and D. none of the above. So, we have always been reading, we always said the sampling frequency must be greater than twice the maximum frequency. So, the question is a little bit confusing. A is a trap, actually we should not fall into A, and C also happens to be somewhere nearer to the answer, but it is not correct also, because the answer is precise, and that is B. Let us look at the fourth question. The Nyquist rate of a signal is A. FM, B. 1 by FM, C. 2 FM, and D. F square m. So, the answer is C, that is 2 FM. Here FM is the maximum frequency of the given signal. So, it should be twice that, 2 FM. Okay. So, the answer is C. Let us see the fifth question. The fifth question is, a signal of maximum frequency of 10 kilohertz is sampled at a Nyquist rate. The time interval between two successive samples is A. 100 microseconds, B. 50 microseconds, C. 25 microseconds, and D. 10 microseconds. So, how do I calculate? Take twice it, that is 20 kilohertz, 1 by 20 kilohertz. Okay. That will be equal to 1 by 20 into 10 to the power of minus 3. The answer is 50 microseconds. So, answer here is B. Let us see the sixth question. A band limited signal has no spectral components above the frequency of 100 kilohertz. The signal can be uniquely determined by its values at uniform intervals of duration less than. So, again you can calculate the same way. The answer is A, that is 5 microseconds. Let us see the seventh question. A voice signal is to pass in low pass filter with a cutoff frequency of 4 kilohertz. The sampling rate is A. 4000 samples per second, B. 2000 samples per second, C. 8000 samples per second, and D. 100 samples per second. So, the answer is 8000 samples per second. Okay, we are talking about a voice signal which is standard here. So, the answer is C. Eighth question. The sampling rate is always between 0 and 2B, 2B and 4B, B and 2B, and 0 and B. Sampling rate is always between 0 and 2B, 2B and 4B, B and 2B, and 0 and B. The answer is 2B and 4B, where B is nothing but a bandwidth. So, it should be, we said twice, isn't it, greater than or equal to. So, it will be between 2B and 4B. The answer is B. Let us see the ninth question. The basic restriction on the reconstruction of a sampled signal is, the sampling must be passed through a low pass filter, B. the sampling must be in the form of an impulse train, C. both A and B, D. none of the above. The question again is, we want to find out what are the basic restrictions on the reconstruction of a sampled signal. So, the A is correct because the signal must be passed through a low pass filter, is what I said. Why are we passing this through a low pass filter? We want to prevent aliasing. So, that is true. A is correct answer. When I look at B, the B also is correct in the sense that I want the sampling to be done in the form of a impulse train. So, A and B in fact are true. Therefore, the answer is C, which says both A and B. 10th question. Which of the following sample techniques is preferred? A. Uniform, B. Non-uniform, C. Both A and B, and D. None of the above. The answer is non-uniform, because we have seen 3 techniques and non-uniform happens to be the most choicest. So, 10B. 11th question. In essence, practical sampling is it A, that is PCM, B, that is PPM, C, PAM, and D, PDM. So, we have, if you have looked at the 3 types of sampling earlier, the answer is PAM, that is pulse amplitude modulation. So, practical sampling is nothing but doing pulse amplitude modulation. If you remember, we have seen that the pulse is following the actual signal that is being sampled. So, the answer is pulse amplitude modulation, that is C. Let us see the 12th question. For a standard 300 to 3.4 kilohertz voice channel, the standard sampling rate is A. 8000 samples per second, B. 400 samples per second, C. 500 samples per second, D. 100 samples per second. So, answer is A. 8000 samples per second. Next question, 13th question. For a nearly distortionless received signal in pulse modulation, it is required that the speed should be dash the signal frequency. A. More than twice, B. Less than twice, C. Less than the signal frequency, and D. None of these. The answer is more than twice. 14th question. If the sampling rate is less than the Nyquist rate, then A. Simpler filters can be used to recover the original signal, B. Bandwidth increases, C. Channel capacity increases, D. None of the above. The answer is A, because B, C are wrong. The answer is A. 15th question now. If the sampling rate is inadequate, then what happens? A. A low frequency alias signal appears in the recovered signal. B. High frequency components are attenuated. C. Aperture effects comes into picture. D. None of these. So, what happens if the sampling rate is inadequate? Then the answer is A. What is happening? A low frequency alias signal appears in the recovered signal. There is nothing but aliasing, isn't it? So, A is the answer. High frequency components getting attenuated, that is B, and C are same, they are aperture effects, isn't it? So, aperture is not happening here, so answer is A. Let us 16th question. The sampling theory is applicable to band limited signals which are A. Single valued, B. Continuous, C. Both A and B, and D. None of these. The answer is sampling theory can be equally applied to continuous and also single valued. So, the answer is C. Both A and B. Let us see the 17th question now. If the non-ideal reconstruction filter is reasonably flat over the message band, its output will be A. X of t, that is the original signal, B. X of t plus spurious frequency components at f less than fs minus b, where b is the bandwidth, C. X of t plus spurious frequency components at f greater than fs minus b, and D. None of these. The answer is you have spurious components plus the original signals. The spurious components are at frequencies which are greater than fs minus. So, the answer is C. 18th question. If the lower sideband overlaps the base bands, the distortion is called A. Crosstalk, B. Crossover distortion, C. Aliasing, D. None of these. So, this is another way of asking the question on aliasing. Now, we are talking about a lower sideband. If it overlaps the baseband signal, the distortion is called as a aliasing. In any way they ask, whenever there is an overlapping of different frequencies, it is called as an aliasing. So, the answer is C. 19th. Another name for aliasing: A. It is called as crosstalk, B. It is called as crossover distortion, C. It is called as frequency fold over distortion, D. None of these. That means aliasing has no other name. But the answer is it is not crosstalk, it is not crossover distortion, but it is in fact C. It is called as frequency fold over distortion, also called as aliasing. So, the answer is C. Let us see the 20th question. The aperture effect in the reconstructed signal from samples is due to the loss of dash frequency components. So, what is the aperture effect? Aperture effect in the reconstructed signal from samples is due to the loss of dash frequency components. A high, B low, C mid and D none of these. Earlier we have seen that aperture effect actually causes amplitude or distortion. And the amplitude is comparatively low for high frequency components rather than low frequency components. So, answer is A. It actually causes distortion to high frequency components. So, the answer is A. Let us see the 21st question. To minimize error, the aperture time is usually maximized, B minimized, C 0 and D none of these. So, we have seen earlier in our sessions. So, you have to maximize the aperture time to reduce or minimize the error of aperture. So, the answer is A. 22nd question. Aliasing can be reduced by A. Increasing the sampling frequency, B. Improving the slope characteristics, C. In fact, both A and B and D none of these. So, the answer is C, where increase the slope characteristics also apart from my increasing the sampling frequency. So, answer is C. Let us see the 23rd question. By increasing the sampling frequency, the bandwidth requirement of the transmission medium A increases, B decreases, C remains unaltered, D none of these. Okay, because there is a band limit, a bandwidth requirements of transmission does not go up because the band limit is there. So, the answer is C, that is remains unaltered. 24th question. If a time function consists of frequency band from 0 to B hertz, then the minimum rate necessary is A, B, B 2B, C B by 2 and D 4B. Okay, it is a band limited only to 0 to B. So, the answer is twice, that is 2B. Let us see question number 25. A voice signal is to pass through a low pass filter with a cutoff frequency of 5 kilohertz. The sampling rate is A 100, B 10,000, C 1000 and D 10. The answer is 10,000, we have to calculate. The answer is B. Let us see the 26th question. 26th question is, during the sampling time, the output of a sample and hold circuit is 0, B constant, C the signal itself and D none of this, sample and hold. So, it will be B, that is it will be constant. 27th. In band pass sampling, the sampling rate is twice A, the minimum frequency, B maximum frequency, C bandwidth and D none of this. So, the answer is C should be twice the bandwidth. If the bandwidth is 2 FM, then it will be twice of that is 4 FM we have seen. So, the answer is C. 20th question. The Nyquist rate for the signal x of t is given as 3 cos 100 pi t plus 10 sin 400 pi t is how much? A for 100 hertz, B 100 hertz, C 200 hertz, D 50 hertz. Earlier we have seen an example similar to this. What you have to do is calculate two different frequencies F1 and F2, find out which is highest and multiply them with 2. So, the highest happens to be 200 hertz here. So, the frequency rate will be 2 into 200, that is A. The answer is 400 hertz. The answer is A. Next question, 29th question. The Nyquist interval for the signal x of t is equal to cos 250 pi t by pi t. So, what is the Nyquist interval? A, the answer is 0.00002 seconds, B 0.004 seconds, C 2 seconds and D 4 seconds. So, again you get the frequency from the given equation, calculate the sampling rate twice of that, then once you inverse 1 by 2 FM will give you the TS. So, the answer is B, that is 0.004 seconds. 30th question. The low pass filter used to eliminate aliasing is called A. Matched filter, B. Interpolation filter, C. It is called as a pre-alias filter and D. Venu filter. The answer is C. It is called as a pre-alias filter. We want to prevent the aliasing from occur. So, the answer is C.